Hello and welcome to my new video. In this tutorial, I'll explain to you what Docker is and give you an overview of why and how you may want to use it in your projects. So we will start by understanding the basic problem that it solves. I will show you the basic tools that you will get and you can use in your projects. And then we will see some examples for better understanding. And then I give you typical project workflows to build, ship and run applications with Docker. So let's get to it. Let's imagine that you are developing some software in your projects, and that software has some code that you have written and well tested. So you want to push that source code onto a new environment and run that on another server. This environment may be testing, staging, or production. And now you are facing an issue, which is that your application is not only your source code. You need to push and deploy other components as well to make your application functional, to fulfill its requirements. So these may be third-party packages that your application depends on, and this may be an application server program or system packages, build tools, and other components. So you're sitting there, you're trying to deploy and ship your application to another environment, and you say, I wish I had something that would encapsulate my application source code and all of its dependencies into one package that I can push to another server and run it with a standard command. And this is what Docker containers do. They encapsulate your application, your source code, and all of its dependencies into one entity. So you can build, ship, and run your application the same way. Docker containers are basically portable environments that contain everything your application needs to run. Let's understand this a little bit better. Docker started out as a containerization technology on Linux machines using Linux containers. This is an operating system level virtualization method in which you're running over the same operating system level kernel, you're running multiple containers. So once you have a server running Linux, then on top of the same kernel, you will be able to run multiple containers. From the containers point of view, they appear to be isolated, standalone Linux machine. So inside the container, it's a separate Linux machine. Outside on the physical level, it's a Linux machine running multiple containers. So this way, a container is an isolated environment and it's a portable environment because you can start up the same container on another machine the exact same way. In order to achieve that, you need a Linux server, plus you need to install the Docker engine. The Docker engine will give you the command line interface so that you can interact with your containers, and the Docker engine will also manage the containers you started up. There are two kinds of Docker containers in production mode. There are Linux containers and there are also Windows-based containers. Linux-based containers run on Linux machines and they run on top of a Linux kernel. Windows-based containers, on the other hand, run on Windows servers and they run on top of the Windows kernel. Docker containers come from Docker images. The Docker image is a file system snapshot of your Docker container. So the image contains your application and all of its dependencies, including the server software that runs your application, like a web server, for example. And it contains all the third-party dependencies, all the system tools, and also your source code. Images come from a Docker registry. A Docker registry is a place to store images centrally. There is one big and public Docker registry online called the Docker Hub. If you go there, you will be able to grab Docker images for free and you can start experimenting right away immediately. The Docker container is a running instance of a Docker image. So by definition, a container is a running application. The image, on the other hand, is a file system snapshot that defines the blueprint of your container. Once you download an image to a computer or server, you can start up multiple containers from the same image. If you are working on a project, probably the centrally available images will not fulfill your requirements. In this case, there is a standard tool that you can use to extend your images to suit your project's needs. The Docker Hub has images for almost any technology that you can think of. So this is the best place to start a new project or a new experiment. We will look at the Docker Hub in the example. Extending images from the Docker Hub is very simple. Docker gives you a tool that's called a Docker file, which is basically a text file that you create on your machine. And then you can use standard instructions to add more files, more stuff into the Docker image. You can use standard instructions to define your images in the Docker file. Use the from instruction to specify which image you want to start from and which image you want to extend. Then you can use instructions like copy to copy files from your local machine into your Docker image. You can use the run instruction to run standard operating system level commands to generate the file system snapshot, meaning the files in your Docker image. Once your Docker file is complete, then you build it with the docker build command, and then you will get the resulting snapshot in the form of a Docker image. What you see here in the example is a multi-stage build. This Docker file has two from instructions, and this means that you can use Docker as a build tool in your project. With the first image, you are building your application, and with the second image, you are going to serve your application. Once you generated your Docker image, you can push it to a central registry like the Docker Hub. A great benefit of Docker is that whatever technology you are using in your images, you can run them and manage them with the same set of commands. So, for example, if you have a Node.js application or you have a Python application, you use the same commands to start up, see the logs, or see the statistics of these applications, no matter what is the technology inside. Most often, your project will need more than one containers, meaning that for the different roles and different levels of your architecture, you may want to define different Docker images, and you want to define how those components work together. For these kind of setups, multi-container applications, you use the compose file. The compose file comes in the form of a YAML file, and you just use standard instructions, just like in case of the Docker file, to build your compose file. The compose file defines your services and then also defines how these services interact with each other and how they work together. Docker provides networks for Docker container interoperability, and you can define Docker networks in the compose file. You can also define volumes, which help you store data outside the container on the host machine. This is needed because containers are destroyed and recreated frequently. They are meant to be stateless. In order to store and preserve data during the container lifecycle, we use volumes to store data outside containers. Docker Compose is not only a file, it's a command line tool. You can use a single command called Docker Compose up to bring up the entire stack. In the example, you see a WordPress MySQL stack. If you start this up, this will work right away. Docker Compose runs your application on a single machine. If you want to run your application on a computer cluster, you can use the same compose file, but you need to use a different command. Docker Stack is the command that you can use to deploy your stack to a computer cluster, and Docker Swarm is the built-in cluster management solution provided by Docker. Let's see the examples now. This is the Docker Hub. On the main page, I see the images that I have created and uploaded to the hub. These are all public, you can also see them. If I click Explore, I will see all the images that I can choose from. These are all technologies that you may want to use on your projects. Just see a few examples like Nginx, HTTPD, Redis, Mongo, and there are many, many more. On the first couple of pages of images, you will see that they are all official. This means that they are prepared by the community, but they are approved by a team in Docker. These images contain best practices, and they are usually very, very well written. So they are a very good place to start your project work, plus they are very great to learn how to create your own images. There is another website provided by Docker called the Docker Store. The Docker Store has a little bit more than the Docker Hub, because the Docker Store has the Docker installation for Community Edition, which is completely free, Enterprise Edition, which is a commercial product, plus on the Containers menu, you see that there are commercial packages here, plus there are also all the images contained here that are also on the Docker Hub. Which one you want to use between the store and the hub is up to you. Let's see how we can grab the official Nginx image from the Docker Hub and start up an Nginx web server with a single command. Let's open up terminal and issue the command docker pull nginx latest. Nginx is the name of the image and latest is a tag. Usually we specify a specific version, but right now latest is good enough. The official Nginx image contains the Nginx server plus a basic configuration. It serves the website by default on port 80. We can start it up by docker run, and then we specify a few options. -d means that it's going to run in the background, and -p 8080 will map port 80 from the container to the local machine. Nginx and latest. The web server is up and running. This is how much it takes to start up a server. Let's check in the browser what is the result. On localhost on my machine, I have a working Nginx server up and running. Let's check out a one-page website that I have prepared for this demo. The structure of the website is the following. It has some source code in HTML, has JavaScript and CSS style sheets. It also has an Nginx configuration directory where I have specific Nginx configuration for this project. What I need in order to run this project is to build it with Webpack, which is a Node.js component. So in my Docker file, I take a Node.js image from the Docker Hub, and then I copy files from my local directory into that image so that it will be available for the build. Then I build it with npm run build. The results of the build phase here will be then copied into the official Nginx image from the Docker Hub. I take that image as the base image for my container that will run the website, and then I will copy the Nginx configuration from here, my project structure, and also I will copy the end results from the first stage to the second stage. As a result of this build, I'm going to have one image based on Nginx that has all these project artifacts inside. Let's see how to build this image. It's going to be built with Docker Compose. I have a Compose file for this purpose. In the Compose file, I'm specifying to build from the current directory, and I'm specifying the name of the image. I also have specified port mapping to map port 80 to 80. So let's go Docker Compose build will build the image for this project. The build has succeeded. Let's see how to run this. First, I need to stop the previous container, the Nginx image, because it takes port 80 right now. I'm using the container name that I see on this list. Then I use the command docker compose up -d to start up the one-page website demo in the background. The container is up and running, and the default network has already been created for this component. If I refresh localhost, then I see the example web page here, up and running. The result of the build with Docker Compose is a Docker image that has an Nginx web server plus the source code for this website all included. I can start up this image in the cloud on a cloud machine with a few commands. First, I need to push the resulting image to the Docker Hub. I use the Docker Compose push command for this. My image has been pushed to the Docker Hub. So now I can go to another machine and pull it. We will start up another machine in the cloud with a service called Play with Docker. You can use this service to play with Docker online. Let's start up a new instance. For the sake of simplicity, I will copy my compose file into this Linux machine. Now with the docker compose pull command, we will pull the image from the Docker hub. Our project's image is on the server in the cloud. I'm using the same docker compose up command to start up the server in the cloud. As you can see, it's running on port 80. Now you see the website appear. This image that we pulled from the Docker hub contains everything to run our application on any server anywhere. So far we have seen the basics of Docker. We understood what it does, we understood how it works, and we have seen the essential toolkit that Docker provides for your project work. Let's see build, ship and run project workflows so that you know how these things are connected. When you work on a project in the build phase, you are focused on the Docker file and the compose file. In the Docker file, you specify your images, which are portable environments for your application components. You also define the compose file that will describe how these components work together and interact. You use the Docker file and the compose file to build your application. Then, once you are ready with your artifacts, you need to use the docker build command to build your images. When you work with Docker, your images will be your deployment entity. Your image will contain the server programs, configuration, and also your source code to run your applications. Once you are ready to ship, you ship your project's images to a central registry. A Docker registry is a standard component. You can download it and you can install registry for yourself. Your organization, your team, your company can have their own private registry. When you push your images to the central registry, then on other servers in other environments, you use the docker pull command to pull your images from centrally, as you see on this figure. To run your application in production, you need to set up your production infrastructure. Once this is done, you can use the central registry to pull your images to the production environment. Docker provides standard tools in the form of Docker Swarm and the related commands to run your application on computer clusters. Let's understand the difference between virtual machines and Docker containers. In case of virtual machines, we have a physical server that has a hypervisor running, and on top of the hypervisor you can have multiple guest operating systems. In this case, we are talking about hardware virtualization, which means that every guest operating system appears to have their own dedicated hardware. In case of Docker containers, the situation is different, because Docker containers are an operating system level virtualization technology. This means that you have a physical server that has an operating system, kernel, and every application that you run on top of the Docker engine seems to be a separate Linux machine or Windows machine. So we are not talking about hardware virtualization, but we are talking about operating system virtualization. This implies that a Docker container is more lightweight than a virtual machine. In case of virtual machines, if you want to use virtual machines to isolate your application components, then you need to add an entire guest operating system as an overhead to the component. While in case of Docker containers, if you are using containers to isolate your application components, the overhead is basically minimal, just the container. You don't need an entire OS for this. Different organizations see different benefits of Docker. It is often the developers who initiate Dockerization. The main reason for this is then with Docker you can build and test your application on the exact same environment that you will be using in production. This reduces the errors that result from environment differences. The so-called "it worked on my machine" problem will disappear most of the time. Docker also improves your CI/CD pipeline because it uses standardized processes and standardized artifacts to build, ship and run applications. If you use Docker, your learning curve for new developers will be much smoother than with other tools. Docker is easy to learn and easy to use. In a legacy environment, you will have the same standard artifacts to be delivered by all of the vendor partners that you have. This will give transparency into the entire process, will give you more control, and will improve quality. If you are a student, Docker is a great way to start experimenting with new technologies. I hope you found this overview useful. You can download the presentation from my blog. I wish you good luck.